Okay, hi guys. So in this lecture, we'll be continuing on seeing more on uh, the speeds of gas particles, which we discussed in the last lecture, which was URMS, UMP, and U average. So we saw that URMS is root of 3RT upon M. Okay. UMP is root of 2RT upon M, and U average is root of 8RT upon pi M. So what is the order? What is the order of the descending order of their values? It would be first URMS, then U average, then U most probable. Obviously, because 8 upon 3.14 is obviously greater than 2, so UMP would be lesser than U average. So the ratio is root 3 is to root 8 upon pi is to root 2. Okay. So if we just look at the graph, then we can see that if we draw the graph of fraction of molecules with speed or U, graph will look like something like this. Okay. So now this would be U most probable, this would be U average, and this would be U RMS. Okay. Next, let's look at another topic, which is collision of gas molecules. Collisions of gas molecules. Okay. So gas molecules are non-interacting hard spheres. First point is gas molecules are non-interacting hard spheres. Okay. Let us first define what is a collision diameter. Collision diameter, or sigma we can write it. So sigma is nothing but whenever two gas molecules come nearer to each other or collide with each other, the distance between their radii is nothing but sigma. Okay, so for same molecule we can write that if the two same molecules collide, then sigma is 2r, and for different molecules, when they collide, sigma would be Ra plus Rb, which is the radii of the colliding particles. Okay. So let me write it that like this way, that suppose a gas molecule rather is colliding with some other gas molecules, and let's say the other two molecules are having the same radii as the colliding molecule. So in this case we want to know, and this gas molecule is going ahead with a speed of, let's say, U average. Okay. So we want to know that what is the volume swept by the gas molecules swept by gas molecule in unit time. So volume would be nothing but in unit time when we are asking, so we can write that U average multiplied with the cross sectional area. Okay, how do we get it? U average will be nothing but distance divided by time into area. Distance into area would be volume, and V by T is volume swept per unit time. Okay, so U average into area. What is the cross sectional area? So this is nothing but sigma, or the collision diameter. So the cross sectional area would be nothing but pi sigma square, as sigma becomes the radii. Okay, and here also the sigma would be the distance would be sigma. So we can say that the cross sectional area would be pi sigma square. So U average into pi sigma square would be the volume swept by gas molecule in unit time. Okay, and we define one more term n star as n upon v, where n is the number of molecules. Okay, and when we divide it by n by v, n star becomes number of molecules per unit volume. Okay, so what would be the number of collisions made by gas molecules in unit time? Number of collisions made by gas molecules per unit time would be nothing but, let us write it as z star. Z star would be number of collisions would be pi sigma square into U average into n star. Okay, because we define n star as number of molecules per unit time divided by unit volume, and unit volume is means the collision volume is pi sigma square into U average. We just saw it in few seconds back. Okay, so this would be the formula, just remember this. So now we took an assumption when we were deriving this form. So assumption was that only one of the gas molecules was moving. During collision. Okay, and now what if let's define a separate case. So case is now, what if the average angle considered is 90 degree and all the gas molecules are moving. So in that case, number of collisions made by gas molecules with other gas molecules in unit time would be nothing but, now we have to define z star for it. So number of collisions made by gas molecules with other gas molecule in unit time or per unit time, whatever you want to say it, would be nothing but z star would be, just deriving from the above form, would be pi sigma square. Still cross sectional area of collision won't change. Now it would be U average relative. Okay, previously it was only U average because the other gas molecules were at rest. So in this case it would be U average relative into obviously N star. And what would be the U average? When two molecules are colliding at 90 degree, U relative would be nothing but root 2 times U average. Just did some vector algebra over here. So this would be Z star. Okay. So with this we come to the end of this lecture. In the next lecture we will be seeing collision frequency, and then we'll be starting off with mean free path. So till then, good luck and goodbye.